Welcome to this calculus lesson where we'll solve a challenging integral. Today, we're going to tackle this integral. The integral of dx divided by sine of 3x plus sine of 2x plus sine of x. This is a challenging integral that requires multiple techniques to solve. Here's our approach. First, we'll simplify the denominator using sum to product identities. Then, we'll make a u substitution with u equals cosine of x. Finally, we'll use partial fractions to complete the integration. Let's begin with step 1. We'll use the sum to product identity to simplify the expression sign of 3x plus sine of x. The identity states that sine a plus sine b equals 2 sine of the quantity a plus b divided by 2 times cosine of the quantity a minus b divided by 2. Applying this to sine of 3x plus sine of x, we get a equals 3x and b equals x. This gives us 2 sine of 2x times cosine of x. Now we can rewrite the full denominator. We have sine of 3x plus sine of 2x plus sine of x, which equals 2 sine of 2x cosine of x plus sine of 2x. Factoring out sine of 2x, we get sine of 2x times the quantity 2 cosine of x plus 1. Step 2, we'll use the double angle formula for sine of 2x. We know that sine of 2x equals 2 sine of x cosine of x. Substituting this into our denominator, we get 2 sine of x cosine of x times 2 cosine of x plus 1. Simplifying, our integral becomes 1/2 times the integral of dx divided by sine of x times cosine of x times the quantity 2 cosine of x plus 1. Step 3, let's use u substitution to make this integral more manageable. We'll set u equal to cosine of x, which means do equals negative sine of x dx. Rearranging, we get sine of x dx equals negative 2. We also know that sine squared of x equals 1 minus cosine squared of x, which is 1 minus u squared. With these substitutions, our integral becomes negative 1/2 times the integral of do divided by u times 1 minus u squared times 2u plus 1. Step 4, we'll use partial fractions to break down this complex fraction. We need to decompose the fraction 1 divided by u times 1 minus u squared times 2u plus 1. This can be written as a over u plus b over 1 minus u plus c over 1 plus u plus d over 2u plus 1. Step 5, we need to find the values of a, b, c, and d. By clearing denominators and matching coefficients, we can determine that a equals 1, b equals 1/6, c equals 1/2, and d equals negative 8/3. So our decomposed fraction becomes 1 over u plus 1/6 over 1 minus u plus 1/2 over 1 plus u minus 8/3 over 2u plus 1. Step 6, now we can integrate each term separately. Remember that the integral of do over u is the natural logarithm of the absolute value of u. Integrating each term and including our negative 1/2 factor from earlier, we get negative 1/2 natural log of absolute value of u plus 1/12 natural log of absolute value of 1 minus u minus 1/4 natural log of absolute value of 1 plus u plus 2/3 natural log of absolute value of 2u plus 1 plus a constant. Finally, step 7, we substitute back u equals cosine of x to get our final answer. Our integral equals negative 1/2 natural log of absolute value of cosine of x plus 1/12 natural log of absolute value of 1 minus cosine of x minus 1/4 natural log of absolute value of 1 plus cosine of x plus 2/3 natural log of absolute value of 2 cosine of x plus 1 plus a constant. Let's visualize what we've done. We started with this challenging integral involving sine functions, simplified the denominator using trigonometric identities, and then used substitution and partial fractions to break it down into manageable pieces. Our approach allowed us to transform a complex trigonometric integral into a combination of logarithmic expressions. This method of using sum to product identities, substitution, and partial fractions is powerful for solving many types of trigonometric integrals. To solve complex integrals like this one, remember to look for ways to simplify the expression first, using trigonometric identities when appropriate. Then consider substitutions that might simplify the resulting expression further. Finally, techniques like partial fractions can break down complex fractions into simpler ones that we know how to integrate. With practice, you'll develop an intuition for which techniques to apply to different types of integrals. Thanks for watching.